Write all the possible isomers of an alcohol having the molecular formula C5H12O and give their IUPAC names. This elemental composition belongs to the category aliphatic saturated alcohols. Just like aliphatic saturated hydrocarbons, this elemental composition belongs to the category aliphatic saturated alcohols. This will fit into the general molecular formula of the type CnH2n plus 2O, and therefore we will not have carbon-carbon double bonds or carbon-carbon triple bonds. This is no, and also they will be non-cyclic because the degree of unsaturation in this case will be equal to 0. If you want to calculate the degree of unsaturation for this, it would be 1 plus number of carbon atoms minus number of hydrogen atoms by 2. Oxygen does not participate in the degree of unsaturation calculation, and therefore this is equal to 1 plus 5 minus 12 by 2, 6 minus 6. So, that is equal to 0. Therefore, all the structures that we are going to write are either straight or branched but non-cyclic. Also, they should not contain carbon-carbon double bonds or carbon-carbon triple bonds. So, let us write the structures one by one. We will write the structures both in condensed form as well as in bond line notation. Let us first write the structure in condensed form, then we will write the corresponding structure in bond line notation. Number 1, we can write pentane 1-ol, that is CH3, CH2, 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 OH. This is pentane 1-ol, and the corresponding structure in bond line notation will be 1, 2, 3, 4, 5, and then the alcohol functional group. Let us number it 1, 2, 3, 4, 5. This is pentane 1-ol. And then number 2, we can also write pentane 2-ol, that is CH3, CH2, CH2, CH, OH, and then CH3. And then the corresponding structure in bond line notation will be 1, 2, 3, 4, 5, and then a 2 position alcohol functional group. Let us number it 1, 2, 3, 4, 5. This is pentane 2-ol, and then we can also write pentane 3-ol. Let us move the OH functional group to the third position. Therefore, that is CH3, CH2, CH, OH, and then CH2, CH3. This is pentane 3-ol, and the corresponding structure in bond line notation will be 1, 2, 3, 4, 5, and the OH functional group at 3 position. Let us number it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is pentane 3-ol. Now, we are exhausted with the pentane chain. We cannot write pentane 4-ol because the reason is, if you put the OH functional group at 4 position and if you number it left to right, then it would become pentane 2-ol. That is a repetition. Therefore, we should not try to write pentane 4-ol. Also, we should not try to move the OH functional group to the 5th position, because if you number it left to right, that would become pentane 1-ol. Therefore, those repetitions we should avoid. So, we are exhausted with the pentane chain. Now, let us move to the butane chain and write alcohols there. So, number 4, let us write the butane chain, that is CH3, CH2, and then CH, and then one methyl group, and then CH2OH. And the corresponding structure in bond line notation will be 1, 2, 3, 4, and then the alcohol functional group, and then at 2 position 1 methyl group. This is 2-methyl butane 1-ol. Let us number it 1, 2, 3, 4. This is 2-methyl butane 1-ol. And then number 5, we can also write 3-methyl-butane 1-ol. We are just moving the methyl group to the third position, CH3, CH, CH3 and then CH2, CH2, OH. And the same structure in bond line notation will be 1, 2, 3, 4 and then the OH functional group, then the methyl group at 3 position. This is 3-methyl-butane 1-ol. Now we are exhausted with the butane 1-ol options. So let us move the alcohol functional group to the second position. Therefore, we can also write 2-methyl-butane 2-ol and that is CH3, CH2 and then carbon and then methyl group CH3 and then alcohol functional group and then methyl group. This is 2-methyl-butane 2-ol and the same structure in bond line notation will be 1, 2, 3, 4 at 2 position alcohol functional group, at the same position methyl group. Let us number it 1, 2, 3, 4. This is 2-methyl-butane 2-ol and then number 7 we can also write 3-methyl-butane 2-ol and that is CH3, CH, CH3 and then CH, OH and then CH3 and the same structure in bond line notation will look like this 1, 2, 3, 4 and then at 2 position the alcohol functional group, 3 position methyl group. Let us number it 1, 2, 3, 4. This is 3-methyl-butane 2-ol and then number 8. We are now exhausted with the butane chain as well. So let us move to the propane chain. We can write one isomer here, that is CH3, C, CH3, CH3 and then CH2, OH and the same structure in bond line notation will be 1, 2, 3 and then the alcohol functional group and then 2 methyl groups at 2 position. Let us number it 1, 2, 3. This is 2, 2 dimethyl propane 1-ol. The reason why we did not put both the methyl groups at one position is because that would become a repetition of 2-methyl-butane 2-ol and that is the reason when we come to the propane chain we are directly entering both the methyl groups at 2 position. If you put both the methyl groups at one position then that is a repetition. This is something you need to keep it in mind. So these are the 8 isomers that are possible for C5H12O containing an alcohol functional group.